Does being creative mean you're right-brained? Or if you like math and science, are you definitely left-brained? More importantly, did a quiz on Facebook give you this idea? For over a century, we've known certain parts of our brain are specialized for certain tasks, noticing that people with injury or damage to specific parts of the brain often lack the ability to do very specific things, like speak, or identify objects, or even recognize the faces of loved ones. Because evolution doesn't care about making sense, the left side of your brain controls the right side of your body. Anything presented in your right field of view is only seen by the left side of your brain, and vice versa. But in your standard brain, that one-sided information can't be hidden from the other, because the two hemispheres are connected by a neuron superhighway called the corpus callosum. When these fibers are plugged in, the brain's two hemispheres work together in seamless harmony, and we don't even notice that different functions of daily life reside in different parts of the brain. But if these cords get cut, it's a different story. In the 1940s, brain surgeons came up with a new way to treat epilepsy, splitting people's brains. A seizure is like an electrical storm that puts the brain in overdrive, so build an impenetrable barrier to contain the storm, stop the seizures. And this actually worked. People with so-called split brains were mostly the same, but doctors started noticing some weird side effects, like when choosing clothes to wear or picking out food, each side of their body was operating independently from the other. Scientists could finally look at what actually happens if the two halves of a brain are separated. And it completely changed our notions of how the brain is organized. When a word is shown to the right side of a split brain, the patient can't say what they saw out loud, but they can draw it with their left hand. Kinda creepy. Normally, motor signals get confused when you try to draw two separate pictures at the same time with each hand, but a split brain patient can do this task as if they're operating each hand completely separately. These spooky experiments showed many brain functions are lateralized. They're generally divided into the left or right side. The ability to speak, for example, takes place in a spot called Broca's area that in most people is on the left side of the brain. Decades of these experiments show that generally the right side of the brain processes spatial and temporal information, the when and the where, and the left side controls speech and language. But that doesn't mean in different people one half dominates the other. More like our brain is arranged in compartments, a collection of fuzzy little modules all working together to form what we know as us. But why use tiny bits of our brain to do complex tasks instead of the whole thing? Basically because our brains are big. We have more neurons than most animals, which means more connections. In fact, we have too many neurons for them all to link up. If each neuron in our brains was connected to every other, our brains would be 12 miles in diameter, and information wouldn't be able to travel fast enough across our neuron networks. Now, smaller circuits mean more efficient heads. Thousands of ants can work together as a coordinated colony without each individual getting instructions from the queen. Our brain combines those functional modules in a similar way, only instead of building anthills, they come together to somehow build that thing we call consciousness. How a unified mind can emerge from a brain made of tiny packages with different responsibilities is one of the greatest questions in not just neuroscience, but all science. And we still don't have a complete answer. But splitting brains in two has taught us that breaking our 3 pounds of think meat into smaller and smaller pieces probably won't solve the puzzle. Consciousness isn't one specific thing we can put our finger on. We could study a symphony by describing the physics of individual sound waves, but it loses a little bit of its beauty along the way. And looking at the function of single neurons in a brain likely won't let us decode how we think and perceive the world. Now, we should understand how the individual instruments are played, but also remember that your brain is more like an orchestra, different sections working together to produce beautiful music. Stay curious.